Welcome back! Today we'll swap the default character with our VRoid model, create a base material to hide clothing slots, and build the customization UI with categories, dresses, tops, shoes, and color sliders. We'll also set up an Enum to switch categories cleanly through the Widget Switcher, just like a professional character creator. Let's jump in!
Open the BP third-person character blueprint. In the Components panel, replace the skeletal mesh with the VRoid character we created in Part 1. In this example, I'll assign SK_Lily as the skeletal mesh asset. Next, let's create a material to hide clothing slots. In the content browser, right-click, Material, name it Base_Matte. Open it, promote the base color to a parameter, and make sure to set the blend mode to translucent. This allows the material to turn meshes fully invisible. Compile and save. Now, back inside the BP third-person character, we'll apply this material. Select all clothing-related slots. Shirts, pants, dresses, tops, bottoms, shoes, accessories, ears. Basically every slot you want hidden. Assign base matte to those slots. Leave only the primary visible outfit and shoes assigned to their original materials. This ensures only one set of clothes shows while the rest remain invisible. Press play, and you should now see the character working correctly with only the chosen clothes visible. Next, let's set up the customization interface. In the content browser, add a widget blueprint and name it WP_character_C for character customization. Create a new folder named WP. Inside it, open the widget. Drag a canvas panel into the viewport. Add a vertical box and set its anchor to the entire left side. Offsets should be set to 0 for X and Y. Now add a button, wrap it in a border, and place an image inside the button. Assign a dress icon to this image. For the button states, hover and pressed, set it to Draw as Image. Also add a text block for labeling. Font size 5, italic style with 0 padding. Give the border a background image, then set the border size to fill. Rename the button Dress B.
_B. Step 5. Duplicate UI elements. Duplicate this structure for other categories. Tops, bottoms, shoes, glasses, arm accessories, head accessories, like cat ears, rabbit ears. Tail color changer. We need to add 2 spacers inside the vertical box, one at the top and one at the bottom, and set their Y size value to 150. Finally, adjust alignment. Select all the text blocks, set vertical alignment to bottom. Label each button clearly: dress, top, bottom, shoes, glasses, accessories, etc. Compile and save. Add a background image. Let's start with the UI background. Open your widget blueprint. Add an image and set its Z order to -1 so it stays behind all other UI elements. Set its position X and Y to 0 and also set its offset values to 0. Choose a background texture. I'm using a purple indigo gradient, but you can use any image you like. Adjust the size until it fits your screen. This will act as the base layer of our UI. Step 2. Add a category switcher. Next, we'll create a system to switch between different categories. Add a widget switcher to the canvas. Anchor it to the left center of the screen. Rename it Category Switcher. Inside the switcher, add a uniform grid panel. Rename this grid Dress_Grid. This grid will hold our buttons for the dress category. Step 3. Create the first button. Inside the dress ground -dress, add a button. Wrap it inside a border, and inside the border, add an image. For the border, assign a decorative texture. For the button, assign a dress icon. Set the size to 100, or adjust to whatever looks best for your design. Set Draw As to Image and padding to 0. Rename this button Dress_B1. This will be our first dress option. Step 4. Duplicate for more categories. Now duplicate the entire border plus button plus image setup for additional dresses within the same grid. Once the dress grid is ready, duplicate the entire grid itself to create other categories, such as tops, bottoms, shoes, glasses, arm accessories, head accessories like ears or hats, tail. Each grid will go inside the category switcher and we'll toggle between them later. And hey, let me share something with you guys real quick. Whenever I'm working on projects like this, I always keep a little notebook next to me. Why? Because when ideas come, they come fast. Sometimes while I'm eating or even late at night. Writing them down means I never lose them. That's honestly how I've been able to build systems like this one, step by step, even when it felt overwhelming. So while you're duplicating grids here, remember, The small, consistent steps you take are what build something big. That's true in Unreal Engine, and honestly, it's true in life too. What is a uniform grid panel? A uniform grid panel is a layout container in Unreal Engine's UMG UI system that organizes widgets, like buttons or images, into rows and columns. The key word here is uniform. Every cell inside the grid is the same size, so everything lines up perfectly without you manually adjusting each element. Think of it like an Excel sheet for your UI. Each cell is evenly sized. You place a button in one cell, an image in another, and they all line up neatly. Why are we using it here? We're using a uniform grid because it keeps all of our customization options, like dress buttons, shoe buttons, or hat buttons, aligned and evenly spaced. If we just dropped buttons randomly on a canvas, they'd look messy, and resizing the screen would break the layout. With a uniform grid, all the buttons are automatically the same size. They stay aligned row by row and column by column. It makes it easy to add or remove items later without redesigning the whole menu. A lifelong analogy. It's like setting up a shelf with equal compartments. You don't want one shelf taller than the other or books falling out because one section is too small. A grid makes sure everything has its place, clean, balanced, and professional. And that's exactly why game UIs use grids. They make the player's experience feel smooth and intentional instead of clunky. Now, earlier we added a widget switcher and named it Category Switcher. Let me explain what that actually is and why we're using it. What is a widget switcher? A widget switcher is a special container in Unreal Engine that can hold multiple widgets, like different menus or grids, but it only shows one of them at a time. You can think of it like a deck of cards. The switcher holds the whole deck, but you only see the top card. Behind the scenes, all the widgets are still there, waiting, but only one is active and visible. Why are we using it here? We're using a widget switcher because our character customization menu has many categories: dress, tops, bottoms, shoes, accessories, etc. Without a switcher, all the grids would appear at once, cluttering the screen. With a switcher, only one grid category is visible at a time. Switching between categories is just like flipping to the right page instantly. It keeps the UI clean, organized, and user-friendly. Real-life examples. TV remote. Think of a widget switcher like your TV remote. The TV holds hundreds of channels, but you only watch one at a time. The others are still there, waiting, but you choose which one is active. Tabs in a browser. You might have 10 tabs open, but you're only looking at one tab right now. The switcher is basically your tab bar for UI elements. Closet with sliding doors. Imagine a closet with different sections: shirts, pants, shoes. The closet has them all, but the sliding door only reveals one section at a time. That's exactly how a widget switcher works. In our system here, each grid, dress grid, tops grid, bottoms grid, etc., lives inside the widget switcher. When the player clicks tops, the switcher hides all other grids and only shows the tops grid. It's simple, but it makes the UI feel professional and easy to use. So, while I'm duplicating and renaming these grids, let me be real with you. This is what actual game development looks like. It's not always fireworks, particle effects, or fancy cinematics. Most of the time, it's these slow, steady, almost boring steps. Duplicate, rename, organize. That quietly build the whole backbone of your system. And you know what? Life works the same way. You don't suddenly wake up one morning knowing everything. You learn a little, you repeat it, you make small improvements, and then one day you realize those basics turned into real power. That's exactly what we're doing here. Brick by brick, step by step. It doesn't feel glamorous right now, but trust me, this is the part that makes the whole thing stand strong later. Step 5. Add the color changer. For categories that need color adjustments, like ears, tail, hair, or eye color, we'll use a slider. Duplicate one of the existing grids and delete the buttons inside. Add a slider instead. Set the slider's horizontal and vertical alignment to fill so it takes up the available space. Rename it, for example, ears_slider. Repeat this process for hair slider and tail slider. Finally, add a text block above each slider to label them, such as ears, hair, or tail. Set alignment to center and adjust the font size for readability. Create the activation actor. Now, how do we actually bring this UI up in the game? We need a trigger. In the content browser, right-click Blueprint Class Actor. Name it BP_C. Add a box collision. Uncheck Hidden in Game. You guys know. If this is checked, the box disappears during play. With it unchecked, we can see the trigger box while testing. This box will act as our zone. When the player walks into it, the customization menu will pop up. Add a custom camera. Inside the third-person character blueprint, add a new camera component. Place it in front of the character so it captures a good view for customization. Adjust until you're happy with the framing. We add a new camera because the default follow camera is too far away. A closer, fixed view makes customization much easier. Step 9. Overlap event logic. Back in BPC, select the box collision. Add on-component begin overlap. Cast to third-person character. Get the new FOV_camera. Add set active equals true so it switches to this camera. Duplicate the set active node. Get the follow camera and set it to false. This is how we make the game automatically switch cameras when the player steps into the customization zone. Step 10. Disable input and show widget. Now, we don't want the character moving around while customizing. From the player controller, call Disable Input. Create the customization widget and add to viewport. From the player controller, call Set Show Mouse Cursor equals True. Create an enum for categories. Now let's set up category switching with an enum. In the content browser, create a new enumeration. Name it EShowCategory. Add entries for every category: dress, tops, bottoms, shoes, glasses, arm accessories, head accessories, tail, color changer. Honestly, enums are like writing a grocery list. If you don't write it down, you end up wandering the store, forgetting half of what you needed. But with a list, you know exactly where you're going. Same with Enums. Instead of chaos, everything is labeled and structured. That's why we use them here. It's not just clean code, it's peace of mind.
Inside the widget, create a function called EshowCategory. Add an input of type EshowCategory. From the category switcher, call setActiveWidgetIndex based on the Enum input.
You guys know enums are way cleaner than hard-coding indexes. It keeps the system scalable, so if you add more categories later, you just add them in the enum instead of rewriting everything. Step 12, hook up the buttons. Finally, hook the buttons up. Dress button on-clicked, show category dress. Tops button on-clicked, show category tops. Repeat for bottoms, shoes, glasses, etc. Now, when you click each category button, the correct grid shows up. And that's it. We built a clean background, created grids and sliders for categories, added spacers for a polished look, built a trigger actor with a box collision, set up a new camera, switched cameras on overlap, disabled movement, showed the widget and cursor, and finished with an Enum-driven category switcher. Now when you walk into the trigger box, the camera switches, the customization menu opens, and you can navigate between dresses, tops, shoes, and more. You guys know, little by little, this is starting to feel like a professional character customization system you'd see in real games. In the next tutorial, we'll make the buttons and sliders actually change the character's outfit, accessories, and colors in real time. So compile, save, test it, and enjoy seeing your customization menu come to life. Hey guys, thanks so much for watching. If you found this helpful, please don't forget to like and subscribe, and let me keep making tutorials like this for you. And I'd love to hear from you. If you have any thoughts, ideas, or even challenges you're facing in Unreal Engine, drop them in the comments below. I always check them, and your feedback helps me know what to cover next. See you in the next episode.